Hello everyone, welcome to the Farnborough International Air Show 2024. My name is Jason Pritchard, Executive Editor, eVTOL Insights, and I'm delighted to be joined by Olaf Otto, President of Rolls-Royce Electrical. Olaf, thank you so much for joining us today.
Thanks for having me, Jason.
Love to hear your thoughts about the market and also about what Rolls-Royce is working on as well. First question, we get asked by many readers, when electric aviation will happen. Are you able to provide a general assessment of the global market at present?
So I'm happy to give you my insight on this one. So I'm always thinking that when I hear that question, there's a little bit of a gap in understanding because electrical aviation is happening already today. So you can buy two-seater aircraft already today. And there's so many people that are working on the eVTOL side that it's something that is going to happen in the very near term. Now, there are companies that have announced that they're going to have aircraft certified within the next year or so. Whether that really is going to happen, I think we'll have to see, because it is a very challenging market with certification requirements that are very, very tough and very new. But it will, I think, absolutely develop within this decade.
Perfect. No, thank you very much for that. And then we also mentioned the crawl, walk, run approach, a term that a lot of the industry is using at the moment as well. But how do you then see the industry scaling up in the early stages when, as you said, electric aviation is happening now? How do you see the industry then scaling up when we get to that stage? And where would you say maybe are the challenges, but also the opportunities as well?
Right. So then it's an interesting question because there are a number of challenges that you have today. So obviously we have to get the supply chain stood up. That's something that if you've read a little bit about it in the newspaper, you know that this is something that the industry as a whole is facing as a challenge. But I think that is something that is going to be resolved within the next few years. But there are definite new areas that you don't have in traditional aviation today. So one is that you need to get to a different scale. And this is something that is very exciting, I think, for anybody who's working in aerospace, to see that you're getting to near automotive levels of volumes that you have to do. So you need new manufacturing methods and also sites and manufacturing facilities that are set up for this kind of level of manufacturing. So I think that's one side of the challenge. The other side of the challenge is related to a question of infrastructure. So imagine you suddenly have 100 or 200 of these eVTOLs around. How are you going to charge them? How are you going to do the maintenance and the service for them? So there's a lot of parallel development that has to happen. And what we've seen in electric cars, which is that there was a little bit of a chicken and egg situation in terms of where do I get the charger in order to charge my car. But if there's not enough chargers around, then it doesn't make sense for anybody to put in a charging infrastructure. I think everybody in the industry is very keen to see that scenario not repeating.
Yes.
That is going to be a constraint, though, in terms of how the industry is developing.
Perfect. Thank you very much for that, Olaf. And then Rolls-Royce itself, big brand working in urban air mobility as well. For those of our audience that might be unfamiliar, can you share a little bit more then about the portfolio of products that you're working on at the moment?
Oh, absolutely. So we have a portfolio that covers everything that stores electrons, moves them around, and then makes them do useful work. So if you're looking at the energy distribution side, if you're looking at the inverters that are required, so the brains of the motors, and then the engines, the motors themselves. Specifically in urban air mobility, we're currently working on producing prototypes for something that I believe no one else in the industry is doing, which is a set of fully air-cooled equipment. So both on the electrical machine as well as on the inverter, so the core parts that make the equipment that actually provides then the energy for the thrust. These are technologies that to date you can only have in a liquid-cooled environment. What we're doing is, as I said, we're building that out so that it can be fully air-cooled. We believe there is a significant advantage that exists there from a point of view of safety as well as maintainability. And we're actually on contract to deliver these engines to a customer in due course. So we're quite excited about that ourselves.
Very excited news, and thank you for sharing that, Olaf, as well. And one of the other questions that our readers does ask about is the current power requirements of batteries and the level need to fly eVTOL aircraft to achieve the urban air mobility we all want as well, but also safely and efficiently too. Are you able to share your thoughts kind of on the power level requirements from the battery side as well, please?
So I think on the batteries, the interesting thing is that there's a number of parameters. So you're talking about the power requirements. If we look at power, then obviously for a VTOL aircraft, you need quite a lot of power on takeoff. And then as you transition into horizontal flight, then the power requirements drop quite significantly. So you do look for battery that is able to sustain something like 2 to 4 C discharge rates, higher if possible, for the takeoff portion. At the same time, you're looking for something that has quite a high energy density as well, and that is able to cycle significantly. So you're trying to achieve 3 aims in one battery, and that's something that makes it very difficult. The big challenge in all of electric aviation is the question of how much energy can I actually carry along, because that limits my ability to carry out meaningful missions. Now, the batteries that we've seen built out and promised into the market to date have hovered around 200 watt hours per kilogram of usable energy. But what I'm very excited about is that I'm actually seeing cell technology coming through now that is pushing that limit upwards. And we're getting companies that are now promising cell technology that is north of 300 watt hours per kilogram. And once you get into that kind of range, 300 to 350 watt hours per kilogram on a pack level, again, you're at 300 watt hours per kilogram, potentially plus minus. And that is something that actually covers 70 to 80% of the use cases that we're seeing. It's still not going to be enough. If you look at extending from kind of the short hop flights into intracity flights and the like. So you do need to look at alternative technologies. That's why we always talk about hybrid electric aviation as well. So you do need to look at either fuel cells or potentially generators to help you to get that energy. An area where we have a collaboration also ongoing, for example, with the company Hyundai, where we're working on looking at fuel cell technology in aviation.
Perfect. And talking on partners as well, great that you're working with companies in the near future as well. But are you able to, again, share with our audience some of the partners that Rolls-Royce is working to, again, make a UAM a reality as well? Are you able to tell our audience a little bit about some of the work that you're currently doing at the moment?
So I can't tell you any of the names of the companies that we're working with, unfortunately. But as I said earlier, we are on contract to deliver electrical propulsion system to an urban air mobility company for them to use in their prototype, in one of their prototypes. We're also partnering now with another air mobility company, and we've just gone through the initial stage of the design for the vehicle, trying to fine-tune our equipment and the aircraft together. In an electrical vehicle, there is quite a lot of optimization work that you can do if you work as a team. I think we're going to be seeing quite a lot of that happening, and more news coming out from our side within the next year.
Excellent. Well, very much looking forward to when those developments do happen as well. And just the penultimate question, Olaf, if you don't mind, is one of the themes is pioneers of tomorrow, the next generation, etc. as well. How does working in an AAM environment then benefit an aviation career, especially as we're, as I said, relating to that pioneers of tomorrow theme?
Oh my goodness, I think there's no better place really to work at the moment. So and it doesn't really matter what your area of speciality is. So even if you're not somebody who is focused on an electrical speciality, if you're looking at mechanics, if you're looking at structural mechanics, if you're looking at thermodynamics, all these disciplines are really required in terms of building out this propulsion equipment. And because of the nature of what we're doing, we have to push the envelope of what is possible even further than is possible in today's aviation world. So You get to work on cutting edge technologies because of the rapid development of our industry. You cycle through a lot of different ideas, a lot of different prototypes in a very, very rapid fashion. You do have to prove out the equipment. So there's a lot more, I would say, early stage prototype that actually gets taken into test and flight tests than you would see in other industries. So if you want to work in an environment that enables you to take your ideas from the idea stage all the way through building out equipment and seeing that tested in real life, getting that experience in terms of a certification environment, because that's where we are right now. There is simply no better place to go than working in advanced air mobility. And because we're actually at the start of the cycle to a certain degree, so a lot of companies that are working in this space, but this is not going to diminish over the next years as the industry actually gets into a stage where we're delivering equipment to the market. The amount of career opportunities is just going to increase. So, come and join us.
Excellent. No, thank you very much for that, Olaf. And then just finally, any final thoughts you wanted to share about the industry as a whole? Excellent overview and insights as always. But is there anything else you wanted to share with our audience just before we finish?
So, I think So this is a perfect example of how it's going to be different in the future. So you come to these eVTOL shows, you're not going to hear any of that noise. So we'll be able to talk very, very quietly. So I think your last question was in a sense already a great wrap up, because it is an exciting place to be at the moment. I think there's still a lot of uncertainty in the market, because no one has yet built the ultimate vehicle that's going to cover all the business and use cases that exist. But so it is an industry that also will see rapid development and new ideas springing up in future as well, and that's why I'm excited to work in it.
Excellent. Olaf, always a pleasure talking to you. Thank you very much for your time.
Thanks so much, Jason.
Thank you.